Okay, this is the problem of the week for the 5th of October. Um, and the title is Frozen Treats. And as you can plainly see, it is a word problem. Um, and just before we get into this word problem and give you a few things to remember uh, about word problems and about the problem of the week, I'm going to take you through the some bullet points I think that are good for attacking word problems. And the first bullet point is to read the problem, which probably you would say, well, that goes without saying. But as we read it, we want to read it carefully. Um, we want to read it for content. We don't want to just skim it. Math word problems, science word problems are often very deep. Um, and as a result, every little word can mean something and change the direction of the problem dramatically. So you want to read carefully. Perhaps you would underline or maybe check off or circle key words as you read through the problem, right? Um, and so when we say read, we're talking about reading it and looking into the details of the question as you do that reading. Secondly, oftentimes drawing a picture is helpful. Um, some people are left brain, some people are right brain. Uh, Pictures can oftentimes get you through difficult problems by breaking it into steps, by breaking it into pieces so you can literally see what's going on a little bit better. So draw a picture, and that often helps. Often in the case of algebra questions, you want to assign a variable, okay, um, or variables. There can be more than one variable in some word problems. Fourth, you would write an equation. Now, we say write an equation. Of course, it could be an inequality, right? Equation refers to a mathematical statement involving an equal sign. But we also have, remember, inequalities uh, utilizing less than and greater than. And don't forget also this write an equation, write an inequality might also refer to using a formula that you might have to have knowledge of, particularly in science courses, right? In physics and chemistry, there's oftentimes formulas that you need to use. And then whatever you produce in step four, you're going to solve that thing. Okay, you're going to solve for your variable, you're going to solve for your unknown. And then finally, and maybe most importantly, maybe we should put a star beside it. You should make sure your answer makes sense. Okay, make sure your answer makes sense. So we're going to read through this question, maybe point out some things and try to utilize these bullet points. But we're not actually going to solve the problem for you. That's up to you to do to get your name into the drawing for the Problem of the Week prize. So Katie went to the local ice cream shop with her three children. And we have punctuation there. So, in doing this reading, to slow yourself down, it's often a good idea to stop at punctuation, think about what was just said, and ask yourself, is there anything I need to note about that? Is there anything I need to write down? Okay. Well, perhaps the only mathy thing in there is that we have four people, right? We have Katie and we have her three children. Okay. And then they name the three children. We've got Chris, we've got Nicole, and we've got Mary. Okay. And Katie makes four. So I'm just going to put check marks on those. Um, they're not really key words, but they could be pertinent to the problem. Right? Katie and the kids each ordered an ice cream cone with 2 scoops of ice cream and various toppings. Okay, so now I'm going to start drawing my picture a little bit here. Okay, so here's Katie, and Katie is smiling because she's getting ice cream, and she's happy about that. And then we got to have some kiddos with her. So here's Chris, and of course he's happy too, and he doesn't have his long hair. He has some hair. He doesn't have long hair. And then we got Nicole. All right, so here's Nicole, and she's smiling too, and everybody's smiling. I scream, you scream, we all scream for ice cream. And oh, she's not, she's a girl, so we better put her up there. At least I think she's a girl. And then we got Mary, and Mary is also smiling, and there she could go, and she also has beautiful long hair. And they each get an ice cream cone, right? So here's an ice cream cone, and I'm not really the world's best artist, but they're each getting an ice cream cone. So I'm just going to do a simple thing. I'm just going to draw the ice cream cones. Okay? I'm just going to draw the four ice cream cones. And say what size ice cream cones. Two scoops is probably enough, right? You don't want to eat too much ice cream. That would never be good for you. So then we got that. Oh, I think there. Okay. So there's each person getting an ice cream cone with two scoops. Okay, so I've kind of rendered the situation for myself. So depending if I work with the picture side of my brain, this could be really helpful. And yeah, other students might not need to do that. Okay. We have various toppings on them, right? So you could have, one had sprinkles and one had a cherry on the top and one had sprinkles and a cherry on top. And then this one was coated. This one had that chocolate candy coating on it. So there we go. So we got various toppings. All right, fine. Two scoops of ice cream in a cone is $1.99. So just the ice cream cone is $1.99. So maybe you'd write that down. It might be pertinent, right? It's certainly numbers. So just the bare ice cream cone is $1.99. But the final cost, right? Final cost, so $1.99, I might underline that. Okay. But the final cost of each cone varies. Okay, that sounds like the word variable to me right there. It varies, it changes based on the number of toppings added, right? So that concept, you understand that concept? We've sort of illustrated it for you here. We got sprinkles, we got a cherry, we got sprinkles and a cherry, we got the creepy candy coating. All right, so you're understanding what that statement means. Okay. Now, here, very mathy. Definitely underlining. Average. That is a math word. Average. Okay, big, bold letters. Average. All right. That is formula stuff. Knowing how to find an average. What does that concept mean right there? That's a formula. That relates to a formula. All right. All right. If the average cost, including sales tax, of these sundaes, I guess, well, Sundays, they called them Sundays here, but I guess they're really ice cream cones. Um, Katie and her children ordered was $2.54. All right. So that's the average cost, $2.54. All right. What was the total cost of all four cones of ice cream? All right. So again, a couple ideas here. The bear cone, $1.99. But then when you start adding toppings, that's going to add money to it, right? So then the average cost ends up being 254. All right. So we read the problem, we looked for keywords, we drew a picture. We didn't really assign variables here. Um, but we did pick out a very key word, the word average, which relates to a formula that you'd want to use. Okay. And then you're going to solve that formula, that average formula, and ultimately you're going to make sure your answer makes sense. Okay. And again, what is that they want? They want the cost of all four. Okay. Not just one, right? But they want the cost of all four. So there's the problem of the week. We hope you'll put in your best effort on this, show all your work, and get your name in the drawing for the prize. Okay? So we'll see how you do.